Hello, welcome to another guest tutorial. Today we have for you Val Head. Val is a web technologist. She is the author of Designing Interface Animation. I highly recommend you check out her book. And with Sarah Drasner, who you might have seen in another guest tutorial video, she and Sarah travel internationally to do workshops called Learn Web Animation from the Experts. Webanimationworkshops.com. So you can check out the link to Val's book and the Web Animation Workshops workshop in the video description. Look at this. Next workshop is in New York, December 8th. That's tomorrow. So if you're, I don't know if you're probably travel back in time and fly to New York, but check out here for their next location and hopefully you want to check out their workshops. So Val's going to show you how to make a nice little springy animation using p5.js, which is a framework that I use in a lot of my videos. And we were just talking about how a lot of times what people do is go and try to find this like complicated physics engine to do that, but you can actually do it quite simply in a way that Val is going to show you how to do, which is really exciting. So I hope you enjoy the tutorial.
So hi everyone, I'm Val Head, and in this little short tutorial, I'm going to show you how to make some really easy spring animations. A lot of times, if you wanted to create things maybe that look like this, or even like something that follows your mouse a little bit like that, people will pull in like a whole physics engine or an entire library just to get a little bit of springiness to make it like real physics. But I'm going to show you how to kind of fake the physics and make your own spring easing yourself in a very easy way. And I'm going to show you this using p5.js, so it'll be in Canvas with JavaScript, but really you can use this technique anywhere you can have access to like run a function every frame. So you could do it in like regular JavaScript with a function running on request animation frame, or any other programming language where you have a function running every frame, because we're basically just going to update some math on every frame of the animation. So right now to start out, I have this little pink ball, and it is following the X position of my mouse. So it's just following my mouse along the X position wherever it goes, and it's kind of, well, boring, because it's not doing any fun stuff like springing yet. So to make that happen right now, we've just got a target of our mouse position, which is the mouse X from p5.js, and we're just saying like, hey ball, go use the position of our mouse for your X position. So we're drawing this circle at the mouse position and 200, so it's just moving along that x-axis. But let's make this a little bit more springy. So we have two values that we're going to use for the spring, and they're just up here. We've got one value for drag, which is a value that needs to be less than 1 for it to work, because we're going to take this away from the velocity of each frame. So if it's 1, nothing gets taken away, and if it's less than 1, a little bit gets taken away. If it's like 0.01, a whole ton gets taken away, and that probably won't look good, but we'll see that in a second. And then we have this variable of strength, which essentially represents the strength of our spring. And that has to be very small, or it doesn't have to be very small, but it looks best when it's very small. A good way to think about it, actually, if you are doing these sort of spring animations, you can imagine the thing that you're animating is like attached to a fixed point with a spring. Kind of like this image from Wiki Commons right here, where this rectangle is attached to something with a spring, and when you pull it away, it just kind of like oscillates back and forth until it eventually goes back to rest. So a lot of the physics engines, or if you want to get super physicsy about it, you might use something like Hooke's law and know the spring constant, but we're not going to do any of that. We're essentially going to create two forces, one pulling the spring away from where it wants to be, and some forces pulling it back as well. So if you're into really exact physics, sorry. All right, so back to our ball, and we'll have our two variables for drag and for strength. So let's start actually using drag and strength while we calculate where our ball should be on any given frame. So right now we have our position setting the position equal to mouse X, but I'm going to get rid of that so we can make it more interesting. And we'll start calculating exactly the position the ball should be and kind of like the velocity it should have for each individual frame. Because you always want it to be heading towards the mouse position, and then it'll get closer and closer and eventually rest there after springing around a little bit. But we don't want it to get there like right away. We want it to be kind of a little bit behind where the mouse is. So I'm going to start by creating a variable called force, and this is going to be our target, which is where our mouse is, minus the position of where our ball is right now. The idea being that this particular spring animation is based on the mouse position, and when the mouse moves, the ball is going to go there. If the mouse moves really far, we'll consider that stretching the spring really far, and it'll have a lot of force. If we move the mouse only a little bit, we're just stretching the spring a tiny little bit, and we don't have as much force. So that's kind of faking that sense of the force that's pulling the spring apart, or the action that's pulling the spring away from where it wants to be. So we'll take our force and we'll actually times equal it to our strength. So what we're essentially doing is saying our strength equals itself times the force. What this is going to do, since our strength is a very small number, it's going to take a little bit away from the force, which makes sense, right? If you're pulling the spring and the spring is a very strong, rigid spring, it's going to take a lot more force to pull it apart. So we kind of fake that bit of the physics by multiplying the number of force, which should be something somewhat large if our mouse moves far, by a small number of our strength, which was 0.1, I believe. So we'll multiply that by our strength, and we have some strength there too. So now we want to adjust the velocity of the ball, because for each frame that ball is going to have some velocity. When it first starts out, it'll be 0, of course, because it hasn't moved at all. But as soon as we move our mouse and the ball starts moving, it'll have some existing velocity, and we don't want to completely wipe that out. So we'll use our velocity, which is a variable we declared further up, and we're going to times equal that to our drag. So that's going to do a very similar thing to our force. The velocity is how far the ball wants to go, but drag is kind of taking away from that velocity. Because remember, our drag is equal to 0.75, so whatever our velocity is, we're taking away just 0.25 of it on every frame, so it's getting slowed down a little bit on every frame. Then we'll take our velocity and we will add our force to it. Plus equals force. And that's going to, since the force is what's pulling it kind of away, or like lengthening the spring, if you want to think of it that way, the velocity and force are working together in the same direction. So we'll add that force on there after we've taken away the drag. And then once we're done those simple multiplications and additions and totally fake physics, we can set our position, which is the x position rather of our ball, to what we've just found out for velocity. So our position is plus equals our velocity. The idea being that for every frame, our velocity is going to be some, essentially positive amount, or some amount that it makes the ball move further than it is right now, or maybe the other way, it might go in either direction. But by adding the velocity to the current position, we just keep moving along in our spring, whether it's left or right, or however it is. So then once we have that, in our draw loop, we're also drawing our circle, like we saw before, and we're drawing it at the position, which is the thing we did all that kind of fake physics math for, drawing it right there and at 200 pixels. So if we save this and run it, assuming I did everything right, run. Now we have a little bit of spring to our ball. So it's following our mouse position only on the x-axis, but we have a spring just on that x-axis as well. Of course, this is a lot more fun when you do it on both the x and y axis, which will give you something a little bit more like this. And in this particular one, I also did it with p5.js, and I used vectors to do the x and y coordinates together at the same time, because that's pretty fun to save that time. But by doing it in both the x and y axis, it's a lot more fun. To show you a little bit how the drag and the strength factors work together, I made this little pen. So this is the one that we were just looking at with our drag factor of 0.75 and our strength of 0.1. It's kind of, soft, springy. If we raise that drag even more, so we take less away from the velocity every time, we get a very much more springy spring. This one will make you dizzy. If we increase the strength of our spring, which is essentially like the spring being so rigid or just like made of really, something that resists being pulled, we get a much more like staccato kind of spring. With this with this little drag, it looks kind of like we have blurred vision, so we might take our drag down a little bit. And this is just like a really subtle one. So you can see even with just these two variables of like drag and strength, you can create some very different springs just with some simple multiplication. It's not real physics, it's not emulating any particular spring in the real world, but it does look pretty springy and it's really responsive, so why not? Some places this is pretty good for. We saw it as like a mouse chaser thing, that's fun. Anything that's like scaling up and down on interaction. This was a particular fun one to make that could be like a menu or something where you just have various dots springing out of each other, out of the same position. So there's a lot you can do with springs, and springs don't have to be hard. You can kind of invent them yourself just with a little bit of drag and strength multiplication. So I hope you found that tutorial fun, and it was really great to be on this channel with you.